Okay, dear students, so today we are going to discuss a topic in circles called radical axis. So let us understand what is a radical axis. The radical axis or power line of two circles is the locus of the point at which tangents drawn to both the circles have the same length. Let us understand by means of this, by taking two equations of the circles. So suppose the first circle is having equation x square plus y square plus 2gx plus 2fy plus c is equal to 0. So that is s equal to 0, the first one. And second one is that s dash equal to 0, where s dash is x square plus y square plus 2g dash x plus 2f dash y plus c dash. Now the equation of the radical axis of the above two circles is a straight line, so that is actually defined by s minus s dash equal to 0. That is the equation of the radical axis. So, how we found it is actually that if any point on the radical axis is x1 comma y1, then then these 2 points are having the length of the tangent will be the same. All right, how we are going to find it out? S minus s dash equal to 0. Let us derive this. Okay, so let's make a visual representation of this problem, dear students. Okay, so let me draw two straight lines first. Suppose this is one circle, and this is another circle. Okay, so equation of these two circles are given. Then so suppose if we take a point, suppose we take a point P with coordinate x1 comma y1. Now from this point, if we draw two tangents to this two circles, if the length of these tangents are equal, correct? So let us draw these tangents. So first let me draw the tangent from the point P to the circle, this one. This is the tangent. And let me draw the another tangent from here. Now let's assume, dear students, that suppose T1 be the point in which it is actually touching the circle S is equal to 0. Suppose this is S equal to 0 and this is S dash equal to 0, and suppose this is the point T2. Then what happened is that PT1 should be equal to PT2, correct? That is what the definition of this point should be, that PT1 equal to PT2. Now we need to find the locus of this point, P, such that from that point, if we draw the two tangents to these two circles, the length of this tangent should be equal. So that means what? PT1 is equal to PT2. Now as PT1 is equal to PT2, that implies what? That implies PT1 square is equal to PT2 square. Correct, na? So now as PT1 square is equal to PT2 square, so what is PT1 square? Let's find it out. PT1 square, suppose we know that PT1 square is equal to, from the length of the tangent, in that equation, that expression, that is S, we just need to replace x by x1 and y by y1. That means it is x1 square plus y1 square plus 2 into g into x1 plus 2 into f into y1 plus c is equal to PT2 square. It should be x1 square plus y1 square. So how to find PT2? just in the equation s dash, that is the expression s dash, we replace x by x1 and y by y1. So what we are going to get, x1 square plus y1 square plus 2 into g dash into x1 plus 2 into f dash into y1 plus c. You see, in dear students, in the left hand side x1 square will get cancelled with x1 square in the right hand side, y1 square in the left hand side will get cancelled with y1 square in the right hand side, c in the left hand side get cancelled with c in the right hand side. And then what we are going to get? We are going to get is that, that 2 into g minus 2 also get cancelled. So we get g minus g dash into x1 plus f minus f dash into y1, that is equal to 0. Correct, dear students? Okay. Now there is one small point, is that it is c dash. So c and c dash will not get cancelled, by the way. So what I wanted to do is that, so I made a small mistake here. So c and c dash, this will be same, it will be different. So this is c and this is c dash. So then what we are going to get is that plus 2 into g minus g dash plus 2 into f minus f dash plus c minus c dash is equal to 0. Correct? So now what we need to find? We need to find the locus of that point x1, y1. So the locus of the point x1, y1 will be what, dear students? So the locus of the point x1, y1 is 2 into g minus g dash into x, because to find the locus we need to replace x1 by x and y1 by y, plus 2 into f minus f dash into y plus c minus c dash is equal to 0. That is the equation of the, the radical axis. Correct? So this is the equation of the radical axis, dear students. Any doubt, please do let me know. And if you notice it, this is nothing but s minus s dash equal to 0, as I said in the beginning. Right? This is nothing but s minus s dash is equal to 0. Now, there are some properties of the radical axis. So what is the properties of the radical axis? Let's find it out. Okay. So, dear students, please look into these points. If both the circles, that is s equal to 0 and s dash equal to 0, intersect each other in real and distinct points, then the equation of the common chord of the two circles is s minus s dash equal to 0. And that common chord works as a radical axis. Correct? If I give you a visual representation of the first point, what I just said is something like this. Is that, so suppose there are two circles. This is one circle. Let me draw the circle properly. And another circle is okay. Now in these two circles, then they intersect each other in real and distinct points. So these are the two distinct points. This is one distinct point. This is another distinct point. Then So let me draw the distinct points in the different colors. So in the blue colors, these are the two distinct points. Then the radical axis will be the common chord, right? So if I draw the radical axis, so this will be the radical axis. You take any point on this blue line and draw two tangents that will be equal in length. Now the next point, dear students, is that if both the circles x is equal to 0 and s dash equal to 0 touches each other externally or internally, then the equation of the common tangent of the circle at that point of contact is s minus s dash equal to 0. Correct? Understood? Third point is that the radical axis of two circles is the line perpendicular to the line joining the centers of the circle. That is also quite evident. I repeat, the radical axis of two circles is the line perpendicular to the line joining to the centers of the circles. If you see in this example, whatever, the diagram, whatever I've drawn. So these are the two centers of these circles. Now if we join these two centers, that line segment, is perpendicular to the radical axis, which is the blue line, which is also the common chord, of these two circles. The radical axis of three circles taken two at a time are concurrent, and the point of concurrency is called the radical center. I repeat, the radical axis of three circles taken two at a time are concurrent, and the point of concurrency is called the radical center. Next point is that the radical axis of two circles bisect their common tangent. I repeat, the radical axis of two circles bisects their direct common tangent. Dear students, we are not proving all these things because these are the information you need to remember, okay, and you need to apply while solving the problems, what we'll be doing in some of our future classes. The next point is that if two circles cut a third circle orthogonally, then the radical axis of the two circles will pass through the center of the third circle. Okay, here I just want to mention that what is meant by the orthogonal. Okay, for example, if you get two curves, I can explain you by means of curves. Suppose there is a curve. Okay, this is one curve, and another curve is something like this. Now there is an angle between these two curves. Though it looks like that how little differently, that you may think that how come it is possible to angle between two curves. We always learn, sir, that angle between two lines. How come angle between two curves? So if you have this query, is that the angle between two curves means, if these two curves are actually intersect at a particular point, suppose this is a point, then at that point, we can draw two tangents to this curve, right? Suppose I draw one tangent that is in the green color, okay, and another tangent I'm going to draw in the blue color. Okay, so these are the two tangents. Now the angle between these two tangents is known as the angle between the two curves. Okay, now if this angle is 90 degree, then it is called, these two curves actually are orthogonal to each other. Correct? I hope you got it point, dear students. Okay, so this is about the the orthogonality. About that, if two circles cut a third circle orthogonally, then the radical axis of the two circles will pass through the center of the third circle. So this is all about the radical axis, dear students. Now, what we are going to discuss about the external and internal contact of two circles. That is the next topic. What we are going to discuss is that external and internal contacts of two circles. Okay, let us consider two circles. The first circle having center at the point x1, y1, and the second circle having a center at the point x2 comma y2, and the radius of the first circle is r1 and radius of the second circle be r2. Now these two circles, either they will touch each other externally or they will touch each other internally. Okay, then we need to find the coordinate of their point of contact. Okay, so let's find it out that by means of a visual representation. So suppose these are the two circles. So this is the first circle, and another circle is that just a minute, let me if you see these two circles touch each other externally. And another case what I'm going to show you, dear students, is that something like this. This is one circle and another circle is this is one. If you see the first one, that here the two circles touches each other externally, and in the second case these two circles touches each other internally. Now what we are going to find, we are going to find the coordinate of their point of contact. So this is one and this is the point of contact. And to find that one, what you need to know is that for the first circle, for the first circle, what is the equation of the, what is the coordinate of their center? For the first circle, if we find that center at the point C1 having coordinates x1, y1 and having a radius r1, and the second circle having center at C2 having coordinates x2, y2 and radius as r2. Correct, dear students? So the first circle is having center at the point x1, y1 with radius r1, and the second circle having center at C2 x2, y2, that is the coordinates, and the radius is r2. Now what we are going to find, we are going to find the point of their contact, the coordinate of that contact by means of x1, y1, x2, y2, r1 and r2. How to find that one? If this two circles touches each other externally, then C1 plus C1 C2 should be definitely R1 plus R2. Correct or not, dear students? If you recall, that definitely they will the distance between their centers would be equal to the distance, the sum of their radii, right? That we have discussed in one of our previous session. But today what we are going to discuss is that what is that point of contact. So this is the coordinate of the point of contact. So if you look into it, so if the two circles will touch each other externally, if C1 C2 is equal to R1 plus R2, and the coordinate of the point of contact is R1 x2 plus R2 x1 divided by R1 plus R2, and R1 y2 plus R2 y1 by R1 plus R2, and they will touch each other internally if the distance between the centers is equal to the non-negative difference of their radii. That is, C1 C2 is equal to mod of R1 minus R2. and the coordinates of the point of contact will be r1x2 minus r2x1 divided by r1 minus r2 and r1y2 minus r2y1 by r1 minus r2. That is their point of contact when they, when these two circles touch each other internally. I hope it is clear to you. So that that what about their the external and internal contacts of the two circles. Correct, dear students. So now the next point what we are going to discuss is about the family of circles. Okay. So just let me bring this particular point about the family of circles. So dear students, what is meant by the family of circles? Okay, family of circles passing through the point of intersection of two given circles. Okay, let me explain you a little bit. If I give you 2 points, how many circles you can construct passing through these 2 points is infinite actually. Okay, if I give you 1 point, then definitely you are going to construct infinite number of circles passing through that single point. If I give you 2 points, then also you can construct infinite number of circles passing through these 2 points. So now let us consider 2 circles. Okay. So the first circle I'm going to draw here, dear students, is that this is the first circle, and the second circle is something like this. Now, what is their point of intersection? Their point of intersection is these 2 points. These 2 points are their point of intersection. Now, through this point, suppose this is P1 and this is P2. Now, through P1 and P2, you can construct infinite number of circles. Okay, and these are known as the family of circles. Okay, let us understand. So suppose the first circle, its equation is s equal to 0. Okay, generally we can write s as the x square plus y square plus 2gx plus 2fy plus c equal to 0. And the second circle is that we can write is that s dash equal to 0. So what is s and s dash? Generally you can write s is equal to x square plus y square plus 2gx plus 2fy plus c. And what is s dash? It is x square plus y square plus 2g dash into x plus 2f dash into y plus c dash. So now, as I said a minute back, that you can construct infinite number of circles passing through the point of intersection of these 2 circles. Now, what will be the equation of that infinite number of circles? So that equation of this 2 infinite number of circles will be something like this. That family of circles passing through the point of intersection of these 2 given circles is something like this. So let me show it to you here. So family of circles, family of circles passing through the point of intersection of the 2 given circles s equal to 0 and s dash equal to 0 is s plus lambda s dash is equal to 0 subject to the condition lambda is not equal to -1. And what is lambda? Lambda is a real number, but it cannot be equal to -1. Why it cannot be equal to -1? The moment it is -1, then you will see that s plus lambda s dash equal to 0 reduces to an equation of a straight line, not an equation of a circle, because x square y square will got cancelled because of minus sign in lambda is equal to -1. So this is the equation of the u vary lambda. This is the equation, that is s plus lambda s dash equal to 0 is the equations of the family of circles passing through the point of intersection of the two circles s equal to 0 and s dash equal to 0. Now you vary lambda, number of real numbers are infinite, correct? So you will get, you vary lambda and you will get different circles. Okay, that is about the family of circles, correct, dear students? Now the next point is that the family of circles passing through the point of intersection of a given line circle s equal to 0 and a given line l equal to 0. It also possible. What is that, dear students? That you have a circle. So let me show you that you have a circle something like this. So let me draw in red color. Suppose this is a circle and also you have a straight line. If you see the point of intersection of these two, these two, one is straight line and one is that circle, is suppose P1, P2. Now through this P1 and P2, suppose this is P1 and this is P2. Through these 2 points P1 and P2, you can have infinite number of circles. And what will be those equation of those circles? Is that s plus lambda into l equal to 0. So this straight line is defined as l equal to 0. This circle is denoted by s equal to 0. Then what will be the equation of those circles passing through the point P1 and P2 is something like this. That means the family of circles passing through the point of intersection of a given circle s equal to 0 and a given line l equal to 0 is s plus lambda l equal to 0. And dear students, here there is no restriction on lambda. Lambda could be any value here, any real number. You vary lambda, you will get different circles. Now the third point what we are going to discuss is that, dear students, is that family of circles touching a given circle at a point and a given line l equal to 0 touches it against is s plus lambda l equal to 0. That means it says that if that line is not intersecting, if it is touching, so what it will be this thing. So if I give a visual representation is something like this, that we have a circle something like, and we have a straight line. That means if we have the equation of the circle as s equal to 0, and if you find that equation of the straight line is equal to l equal to 0, and they in the straight line touches the circle at a single point P, then what will be the equation of, now through that point P you can construct infinite number of circles, and what will be those circles? So the family of circles touching a given circle s equal to 0 at the point where a given line l equal to 0 touches it is again s plus lambda l is equal to 0, like the previous one. Correct, dear students? So this is the visual representation in the left, and here is the equation of the circles, family of circles. The next point, dear students, is that family of circles touching a given line l equal to 0 at the point x1 comma y1 on it is something like this. So let me write it down, dear students. The point here is that the family of circles touching a given line l equal to 0 at the point x1 comma y1 on it is x minus x1 square plus y minus y1 square plus lambda into l is equal to 0. The next point what I'm going to tell you, dear students, is that family of circles passing through two given points. Suppose 2 points have been given to you, then how you can find the family of circles. As I said a few minutes back, if 2 points are given to you, then you can construct infinite number of circles. So what will be the equation of such infinite circles is obtained by this one. That family of circles passing through the two given points x1, y1 and x2, y2 is x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus lambda into the 3 by 3 determinant xy1, x1, y1, 1, x2, y2, 1 is equal to 0. That is the family of circles. Okay, dear students, so these informations, you need to memorize so that you can apply as and when required during solving the problems. So this is about the family of circles. Okay, so with this, I will just like to tell you that we are done with the family of circles. Now, the next point what I'm going to discuss is that about the orthogonal intersection of two circles. As I said, dear students, few minutes back, that two curves are said to be orthogonal to each other if their angle of intersection, that is the angle between the tangent at the point of their intersection to the two circles, is actually normal to each other, or the angle between them is actually 90 degree. That is called orthogonal intersection of two circles. Okay, so let me first bring this topic and let me explain you in the next page. So what does it mean by orthogonal intersection? Suppose we are going to draw the two circles. Okay, so here is the first circle and another circle is something like this. Correct, dear students? Now, at the point of their intersection, okay, where is their point of intersection? The point of intersection is this. Okay, and this other point of intersection is also there, but let us focus on this point of intersection. Suppose P1. Okay, so this is the point P1. Now, dear students, at that point P1, we can draw tangent to both the circles. So suppose I'm going to draw a tangent to the circle, in the green color, to the first circle. So this will be the tangent. And for the second circle, I'm going to draw the tangent in the purple color. Now, if you look into these two tangents, that one in the green color, okay. So if I say this is as L1, so or I can say this is T1, the tangent 1, and this is T2. If these two tangents are perpendicular to each other, then we can say that these two corresponding circles are orthogonal to each other. Correct, dear students? Now, if we consider the equation of these two circles as S1 and S2, then how we are going to look into it? Suppose let's find that equation of these two circles as S1 equal to 0 and S2 equal to 0, where so as I say, suppose this is S1 equal to 0 and this second circle is S2 equal to 0. That means S1 is represented by x square plus y square plus 2g1x plus 2f1y plus c1, and S2 is represented by x square plus y square plus 2g2x plus 2f2y plus c2. So these are the two circles. Okay. Now, what is their center then? Then you can know what is their center. It is pretty simple. Okay. The center between their centers will be something like this. Correct. Now, what we can find is that, dear students, is that we will get, if we assume their radius is something like this, R1 and R2. If the first circle radius is R1, so then what we are going to get it is that R1 square plus R2 square. So R1 square will be what? We know that R1 square is equal to G1 square plus F1 square minus C1, correct? And R2 square is equal to G2 square plus F2 square minus C2. That is the R1 square and R2 square. So what we are going to do, dear students, we are going to find the value of R1 square plus R2 square. And we are going to find some important information. Okay, so we are going to find the value of R1 square plus R2 square. So if it is R1 square plus R2 square, so what we are going to get is that G1 square plus F1 square minus C1 plus G2 square plus F2 square G2 square plus F2 square minus C2, correct now? R1 square plus R2 square. So then what we are going to do, dear students, is that from here what we can write is that that is equal to the condition for them is that, so suppose the corresponding circle's center is at this point. So this is the point of the point which is the center, that is C1, and this is the center of the second circle, that is C2. Now if we join C1 C2, so then what will happen, that C1 P1 is nothing but R1, and C2 P2 is nothing but R2. Then what we are going to get is that C1 C2's whole square, C1 C2 square should be equal to R1 square plus R2 square, isn't it? So let me write in a different color. So what I'm saying is that these two circles will be orthogonal to each other if C1 C2 complete whole square is equal to R1 square plus R2 square, because the angle is 90 degree. From the Pythagoras theorem, by applying Pythagoras theorem in the triangle C1 C2 P1, C1 C2 P1, we get C1 C2 whole square equal to R1 square plus R2 square. So what we get, R1 square plus R1 square plus R2 square is something like this. Okay, dear students, so that we are getting it. Now let's find what is the value of, so let's give this is an equation 1. And we are going to find what is C1 C2 whole square. What is C1 C2 whole square? We know C1 is minus G1 comma minus F1 and C2 is minus G2 comma minus F2. So what is C1 C2 whole square? That is G1 minus G2 whole square. G1 minus G2 whole square plus F1 minus F2 whole square. So that is equal to what, dear students? So from here we can write C1 C2 whole square is equal to G1 square plus G2 square minus 2G1 G2 plus F1 square plus F2 square minus 2 F1 F2, and that we give an equation number 2. Now dear students, if you look into equation 1 and equation 2, for condition of, what is the condition of orthogonality? The condition of orthogonality is that C1 C2 whole square should be equal to R1 square plus R2 square. So condition of orthogonality is C1 C2 whole square, that should be equal to R1 square plus R2 square. Now let's find what is C1 C2 whole square. From equation 2 we get G1 square plus G2 square minus 2G1 into G2 plus F1 square plus F2 square minus 2 F1 into F2, that is equal to R1 square plus R2 square. From equation 1 what we get? G1 square plus F1 square minus C1 plus G2 square plus F2 square minus C2. Correct, dear students? So G1 square in the left hand side will get cancelled with G1 square in the right hand side. G2 square in the left hand side will cancel with G2 square in the right hand side. Similarly, for F1 square and F2 square in the left hand side will get cancelled with the corresponding terms in the right hand side. So then what we are going to get, dear students? So the conditions what we get is that C1 plus C2 should be equal to 2 into G1 G2 plus F1 F2. 2 into G1 G2 plus F1 F2. So this is the required condition of orthogonality of two circles whose equations are x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0 and x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. So we are done with the orthogonality of the circles. So with this I would like to conclude the class here, dear students, unless you have any specific question for me. Okay, thank you very much, and we will have our class in the next session, that is tomorrow. Thank you very much.